So this is a nice question from geometry. So let's see how we can solve it. But for that, please do like, share, subscribe, and please support this video. So in this square, we are given a square, and there is a circle and another square inside that square. So first of all, let's label this figure. So suppose this is A, B, C, D, and suppose the center of the circle is O, and let's label it as suppose E. Suppose this point as F and this as G, right? Okay. And pardon me for this drawing because I'm not good at drawing, so that's why it's like this. Okay, so let's see how we can find the solution, that is the radius of this circle. So it's easy, not that much tough. Okay, so let's see how we can find it. So let me draw this figure again over here, and let me tell you some concepts which I'll be using over here, right? Okay, so this is the figure. So now we have to find the radius of the circle. So how we can find the radius? Well, there can be multiple methods to solve this problem, but I'll be telling the simplest one. So what you can do is that you can draw this radius and this radius. Okay, notice that this is a tangent to the circle, so it will be 90 degree, and this will be also 90 degree, correct? And since this is square, so this angle will be 90 degree because ABCD is a square. So this angle will also be the right angle, that is 90 degree. Hence, this figure, suppose I label it as X, Y, we have named this XOYD, okay, whatever. So, what we can do is that now we will find this length, okay. Well, why I've drawn the diagonal OD? Is it required? Well, let's see. So, let's join OB also. Okay. Now, suppose if this is point O, and suppose this is B and this is B, right? So what is DO? Well, it will be like this, and OB it will be like this, correct? And this will be BD, right? But my claim is that BD is equal to BO plus OD. So I have to prove this. How I can prove it? Well, we all know that OD is a diagonal of this square, right? Hence, angle ODY will be equal to 45 degree, right? Since it's a square, right? And since ABCD is also a square, hence angle BDC is also 45 degree, right? Which means that DO and BD are lying on the same line. By line I mean, suppose this is a line, this is the line segment, that is a diagonal over here, suppose BD, or I should write it like this, BD, and there exists a point over here, right? So OD, that is OD and OB lies on this line, right? So from this we can say that BD is equal to BO plus OD, right? Okay. Now since we have proved this claim, now let's work on this. Okay. Now BO can be written as 2 root 2 since diagonal is equal to side length into root 2. Why? Because this is R, suppose this is L, this is L, so it will be L square plus L square is equal to S square, hence S is equal to L root 2. BU is equal to, sorry, this is BF. BF is equal to 2 root 2, right? Now what is BO? Well, BO is equal to BF plus OF, right? So we have, it will be equal to 2 root 2 plus what is OF over here, it is equal to R, correct? So we have BO is equal to this length, correct? Okay. Now we have to find the length OD. Well, OD is equal to R root 2, simple, because it is the diagonal, so length of diagonal is side length into root 2, correct? Hence BD is equal to BO plus OD, correct? Hence we have this length, this will be equal to, this is 4, so it is 4 root 2 is equal to the quantity 2 root 2 plus R root 2. Now from here you can clearly solve for R. So let's see what we get. So we get 2 root 2 is equal to R times 1 plus root 2, correct? Okay. So we have 2 root 2 divided by root 2 plus 1 is equal to R. Now this can be also an answer, or you can simplify, that is rationalize it. You get 2 root 2 minus 1 divided by root 2 square, that is 2 minus 1, that is 1. So it is equal to 4 minus 2 root 2. So radius of this circle is equal to 4 minus 2 root 2. So R is equal to 4 minus 2 root 2. That is the answer. Okay. So if you enjoyed this video, if you did, then please do like, share, subscribe, and please support this video.